Do you hear them? This is fifth hour. This is fifth hour. This is what I deal with every day. This is how loud they are. Takes me forever. Got one kid bouncing around the room. Finally got him to sit down. And now I'm going to have to get him going. Okay, here we go, guys. This is what I want you to start class with. Okay? Actually discuss within your groups, little pods, little common core, let's all do everything together stuff. This homework question. Because actually I looked through first hours and I collected their homework and then did it as bell work, and not many people did it right. So actually, let's take a look at that right now. Fine. So, to recap, where are we at this point? Because I got up to 3 groups and a couple have to go in this group still. A, you make a sealed bid. B, the winners win the bids, but they pay for it and put it in a compensation fund. C is weird, or step 3. You take all of your bids and divide by 3, and that is your 33% fair share value, but it doesn't quite work out that way because your bids are different compared to other people. And the reason you may have bidded lower is maybe you didn't really want the object, but you at least want some compensation for it. So your bid should be close to a fair bid, or else you're giving yourself a disadvantage. We talked about that yesterday. Overbids, you overpay. Underbids, you will get a little bit less than what might be the worth of the object divided by 3. Blah, 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 blah. Subtract this money comes out of that compensation fund paid by the winners. Then there's always a leftover. So divide the leftover by 3 because there's 3 people and fairly distribute that. Then at the end, the reason I'm also covering this is maybe to clean up. How do we make this look? And I kind of did this in a way like I did 1 and 2. I think this is the smartest. Because it says, for each item, which woman is the highest bidder. We went through that. I had them color-coded in green. How much money is placed in the compensation fund? That was step 2. I had that up there. Now, C will answer it all together. C, you had to do all this work, though. So you had to do all this work for C. Now, label everybody. So here we go. I am taping, right? Am I? Yes. Thank the maker. If there is one in a public school. All right, here we go. I started with Judy. What did Judy go home with? First of all, what did she take home with her right off the bat? The piano and the what? Sculpture, right? So this is how I represented that. And I think this is how you do this at the end and how you answer which item does which woman get, how much money does she pay, how much compensation does each woman receive. Just put it all in one little thing. So just answer, what does Judy get? Does she pay or does she get money? And what does she go home with? So that would answer all of those questions. So she paid $5,000 for the piano, $400 for the who? Help me. Sculpture. But then back out, she got 1/3 of her perceived value. That's the $25.40. And then back out of the compensation fund, she got 1/3 of the leftovers. Add these numbers together, and you get a negative, which means she what? Or not lost. Let's not say she lost. She pays $2,559, but she goes home with the piano and the sculpture. Who's the C lady? You know how I am with names. Vicky. Oh, you're online now on YouTube. Sorry. Who's C? Kathy. So what did she go home with? What did she go home with? The lamp and the armoire. Let's all say armoire together. Armoire. I don't know. Who cares? I don't have the time for this. So she paid $35. She paid $3,000. She got 1/3 of her perceived value back of all the objects, her bids. That's why you got to bid fairly, or else you're messing yourself up. And then 1/3 of the leftovers. She still pays. So when you add those numbers together, she came up with a negative number. So that means she pays $304, but gets the lamp and the armoire. Now, I didn't write the last one, which is Sharon. Sharon, quite simply, gets two numbers. She gets this in cash and this in cash and goes home with nothing. But she just gets the cash perceived value. So you'd write that down and then go from there. Uh-oh, wait. Hold on. Hooray! How many people feel they did that right in their homework? Raise your hand. Okay. You didn't even do your homework, sir, so I have no idea why you're raising your hand. The spider in the boat story. Okay. Now, there is the last. This is it. This is it. This is your last map. Your last little how to do this little scenario of fair sharing, but a different version of it. I don't know what else to say. I will tell you a little stupid little story that's true. First hour didn't believe me. It's sort of along these lines. I see people writing. I want them to listen to my little stories. I love Samuel's stories. No, you don't. All right. When we go out to dinner a lot. Actually, probably too much, especially over the summer. That's why I was gained 10 pounds over the summer. But anyway, sometimes we're at odds, where we all want to go. So I give everyone a piece of paper, and we'll pick 4 restaurants. This is true. And I actually do it. It depends how we do it. I say label 1 as your favorite restaurant, then 2, then 3, then 4. So one will say Chili's, one will say a place by us called Doc Rots, one will say Scooters, and one will say Texas Roadhouse. Everyone goes in their separate areas, puts 1, 2, 3, 4, and then we give Dad all the sheets. Mom, Dad, and the 3 girls all get their votes. Then we put all the sheets together, and then I organize them by restaurant. Which restaurant wins? The one that has the most points or the least points? No, actually, I said your favorite restaurant, we put what? A 1. All right, so which restaurant wins? The one with the least points. Right? And that's kind of like a fair share voting of at least, hopefully, we get something that someone put at least a 1, 2, in the worst case scenario, a 3. Because if we put a 4 on there, that would be kind of a high situation. So it's a method of points in a way. It is fun. This is a little different. Maybe not so much fun. Oh, I just heard a sigh of they're gasping for air in this math class. Drowning in air and math air. Okay, number 1, it's different. And I think that's a more direct way. I like it. We have fun with it, and we haven't done it in a while, but it is true. Instead of that, this is we're assigning a point value on stuff that ends up equaling 100 points. And in this scenario, one of them, I'll just be honest with you, the best way this will work is if we have 3 people picking one of 3 things, and someone's going to get 1 thing. All right? My restaurant doesn't work because I have 5 people choosing 4 restaurants, so that's a different scenario. Or 4 people getting assigned 4 different things, and everyone gets 1 thing. So what the 4 people do is they look at the 4 things, they put point values on the 4 things. The points have to add up to 100. The thing that they favor most, they put more points on. And then they have to sit there and think about themselves, how many points should I put on each thing? I think there should be conditions. You don't have to worry about this. I know you're writing, and hopefully you listen at the same time. I think there should be conditions, like you can't put a 0 on something. I think that would kind of skew the results. I think a minimum you should have to put on something is a 10. Blah, 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 blah. Just kind of talking out loud. Now, again, with a map, without you actually driving the map, you don't get a feel for it until you kind of, experience the drive. And then after doing it, you may not need the map anymore. Doesn't that make sense, right? That's a great analogy. Okay? You have to have the map in front of you, follow it, and then after you follow it once, then you don't necessarily need the map to go to that spot. This is really abstract. Like when it's going to be like you're not going to understand the words you're writing. Now, with 3 people, $9. What's a fair share between 3 people? Very simple. $3. What percent does that represent? 33%. So in a fair share situation, everyone should get at least 33 and a third or higher. It's not going to happen in this case. Okay, unless everyone assigned 33 and a third on every value if there was three things that they were choosing from. What we're trying to do, though, is get as close as possible to that through this little situation that you're writing down. It's not going to happen, though. Someone is going to get shortchanged that 33 and a third situation because I am going to start with three people getting three scenarios. I'm going to teach you a new math that you may not have seen, you integrated math people. Okay, here's how this works. If I have three people getting to choose three items, watch this algebra 2ers, and you'll know what this means. So there's three items. 1, 2, 3 items. Okay, now this is your answer to your question. How many different people could select the first item? Just answer that question. How many different people could select the first item? 3. Okay, somebody selected the first item. How many people now can select the second item? 2. Someone selected it. How many people are left to select the last item? 1. 3 times 2 times 1 is what? 6. This is actually equal to what mathematically, algebra 2ers? 3 factorial. I'm going to pause the video because someone just fainted. What was that symbol? It's ugly. 4 people choosing 4 items. How many people can choose the first item? 4. Well, I chose it. How many people now? How many people now? How many people now? That's equal to 24, which is the math symbol, 4 factorial. So I just taught you factorials in the middle of a class. Actually, I just taught you a symbol. So what's 7 factorial, which is the painted behind the right? It's 7 times 6 times what? 5, 4, 3, 2, 1, blast off. Now that's going to be a huge number. All right? But I just thought I'd share that, and I actually had that written. Did you guys see that? And then I had to erase it? Yeah, because I forgot that was there. But anyway, this is why this occurs. All right, now, here's what happens. In this first example is I won't call it the worst case, but it's the one that involves the most work, I guess, or the most thinking. And then what we have to do is just get through it. So after we do this, we find each arrangement and we list them out in a chart. Okay, so that is tough you'll have to wait to see that. That's the map analogy. So identify the smallest point value in each arrangement. Again, you don't know what this means yet, but what I'm going to have, we're going to have 3 people with 3 objects. We're going to have all 6 scenarios laid out, and all 6 scenarios with their numbers that they chose. And then we're going to look at all 6 scenarios and find the smallest value. From that, this is the best case that could happen because it's over then at this point. If there is exactly one and only one arrangement for which the smallest number is the maximum, then that is how this is going to be disseminated to the people. You get this, you get this, you get this. It's over, and you're stuck with it. If, on the other hand, you look at these 6 scenarios, and there's a tie, you eliminate all the other ones, and you move the tie to the next level, the next step 4. Okay, now again, this is a map. I don't know how to get to California just by looking at this map. I gotta wait till I get there so I feel solidified about that. So now, step 4 only happens if there's a tie in step 3. Step 3 was looking at the minimums. Step 4 is now looking at the middle values. Now, of the remaining situations that are still valid with the tie from the small values, if there is a biggest middle left over, then that's what's going to be disseminated to the people. And it's over. If there is yet another tie with the middle values, then you have to go to the last step, which is For the arrangement kept in step 4, identify the largest point value of the big numbers and select that. And that's exactly what's going to happen in this first example. We're going to get a tie in the minimums. We're going to get a tie in the medium values. So therefore, we have to go to the last remaining things. What is the maximum value between those? So again, this means nothing until we actually do it. All right, here we go. The reason I brought that aforementioned teacher out, I'll be honest. She taught this class last year, and these are her notes. I stole them. All right, because it's a new prep for me, and it's driving, it's kind of tough. Fumble. Oh, man. Hope that student's okay. Batteries everywhere. All right. So silly. Anyone know Mr. Voigt? Don't say anything, but just yes or no. Okay. So, I hate him. I love him. All right. Dorncott still here, right? McGrath, she gone. Common Core. Killed her. All right. No, I didn't kill her. She's alive. But she went to a non-Common Core state. All right, fine. It's online. There you go. There's 7 more seconds to the list. All right. This is silly. Again, ridiculous. Like a math situation. A math situation where, yeah, right, cows, horses, and pigs. And, we're really going to worry about feeding those. It's okay. But this is what happened. Mr. Voigt, Mrs. McGrath, and Mrs. Dorncat? I don't know who it is. Married Mrs. Dorncat? Okay. Are asked, would you rather feed the pig, the horse, the cow? Fine. Just play with the scenario. So what all 3 of these people do, they go off to the side and think, all right, what would I rather do? I know it's a silly situation. So Mr. Voigt says, you know what, I really like the cow. So I'm going to put a 50 on the cow, and I like the horse a little bit better than the pig. So I'm going to put a 30 and a 20. And what do those add up to become? 50. So their point values are based off who they would rather care dealing with. All right, got it? Then we go to McGrath. I really don't like the horse. I like the pig and the cow equally. I like the pig twice as much as the horse. So that's how my numbers could work out. Since I like these equally, 40 and 40 and 20, she'd have to get those numbers figured out in her head to add up to 100. So she kind of plays with it a little bit. That's a perfect little scenario for me. I like the pig and the cow twice as much as the horse. 40, 20, 40. Then Mrs. Dorncott says, I like the pig twice as much as the horse, and I really don't like the cow at all. I don't want to deal with the cow. Remember what I said? Probably shouldn't put a 0 on something, and that's probably how you should start the scenario out. So I have to put a 10 on the cow, and then 30 and 60. All right. How many people are there? Assigned to how many things? How many people are there? 3. So there's 3 possibilities to deal with the pig, and then what? 2 possibilities left over for the horse, and then what? 1 left over. So there's 6 possible ways this could shake out. Or it's very simple. Watch how I do this. Boom, boom. Boom, boom, boom. And I can explain each way how come this is. And then actually in Algebra 2 back in the day, we did do charts like this to figure out how does it become 6 different ways. It could either be Voigt gets the pig and then just go diagonally. McGrath would get the horse and then Dorncott would get the cow. Or Voigt would get the pig, Dorncott would get the horse, and then McGrath would get the cow. And that's the only 2 ways different that Voigt would end up with the pig. It's the only 2 ways it could work out, right? Or McGrath could get the pig. That would give Voigt the horse and Dorncott the cow. Or McGrath, Dorncott, Voigt. And I think I did that exactly what was written here. Or the only scenario we've not talked about is, what if Dorncott gets the pig? Then it could go diagonally up this way, or Dorncott, Voigt, McGrath. So the first thing you should do is assign how you're going to label this out in your columns and rows. And really what's being assigned is pig, horse, and cow. So therefore you go to the teachers and put all the possible 6 scenarios that you have. Holy crap. Just think about this. What if it was 4 people assigned to 4 things? How many rows would we have? No, we already did this on the last page. 4 people, huh? 24. McGrath had an example with 24 of these, and then you had to go through a whole process of figuring that out. I cut those out of the homework. We kept it at 3 because I just want you to know the idea. All right, not being like not saying that. I just wanted to keep it that way because even doing this one, dealing with the numbers, I kind of have a headache. So now we put numbers on there. What's Voight's pig number? 20. You know what I like? That's 20 and 20. Put them both in there. What's McGrath's horse number carrying? 20. What's Dorncott's cow number? 10. Now, you know what I did? I finally figured this out. I don't want to go through every scenario right here. Is Dorncott in this column anywhere else? Of course she is. Where's she at? Third one. That's still a 10. Is McGrath in anywhere in this column anywhere? Yeah, where's she at? Down here. So that's also a 20. So get all the numbers out of the way so we don't have to keep looking up in the chart back and forth. Then at the end we can go ahead and do this. So what's Dorncott's horse number? 30. Is she anywhere else? Yes. So that's what I figured would be the smartest thing to do. What's McGrath's cow number? 40. Is she anywhere else in here? Down at the bottom. So get them over with so you don't have to keep looking up back and forth. This will speed up the process. So once you get all the people in there, then you can do this a little bit expeditiously. Did I just make up a word? Alrighty then. Now what do we do? Here's the map. Find the map. Find the map? Is it find the map? I'm the map. No, it's find the map because they're trying to find the map. Oh, whatever. I think I'm right on this one. Oh, okay. I don't know. All right, they're all fighting. Okay, so here we go. Now it's step 3. For the arrangement, identify the smallest point value for every snenario. Okay, so let's do that first. That's the first sentence of step 3 before we actually, make some, do some math with it or whatever, if you want to call it. Smallest number, I'm not going to, come on. You can identify smallest numbers, although first hour when I was doing this, I was hitting a lot of wrong numbers. Was that right? Did I just hit all the smallest numbers correctly? Let's just double check Mr. S isn't insane. Oh, he's insane, but okay. Now, here we go. If there is exactly one arrangement for which the smallest number is a maximum, use that arrangement. So if there's only one that has the highest number and it's unique, then we're done. Is there a tie somewhere? Yes or no? Oh, yeah. Where's there a tie as far as the numbers being the same? When I look at these and it's the highest. What's the highest minimum value? No, what's the highest minimum value in each? 30. Do you see only one of those? No. So I think I know what you were doing there. See, this right now is 30 and 30. So that's what this means. There's a tie. By the way, what's 30 close to? Remember I was talking about fair share value? 33 and a third. So these people will be somewhat. Somewhat. Man, the sound of my voice just must be so melodious for you. All right? He plays my videos at night just because he doesn't have he has insomnia. So I put him to sleep. All of these are out. All of these are out. Because I wanted the minimums in all of these, and these are the best minimums. And think about it, they're close to 33 and a third %, which would be a fair share value for 3 people. But there's a tie. So now I'm back up at step 3. There was not exactly one unique maximum. There was 2. So I must go to step 4. Now step 4 is identify the middle point value, or the one in between. Okay, and if there is one and only one maximum there, we're done. If not, then we must proceed. So, We had a tie for a shared non-unique minimum, so we must go back to the chart of the remaining two. These are out. And now we identify the middle is probably not the best one, the one in between, not the high. So who should I highlight here, 40 or 50? 40. Who should I highlight here, 40 or 60? Oh, for the love of dog, it's another what? Tie. So there was a tie here at 30 for the lowest values. Why am I putting I don't know what I'm putting there. And then there was another tie for the middle point values. Like I said, this is the worst case scenario, the one where you have to do the most amount of work. All right, well then which one do I choose? Our maximums that we have left is 50 and 60. Which one do we choose? 60, because I guess we're trying to make someone happier than somebody else. So this is how this gets laid out. McGrath gets the cow, Dorncott gets the pig, Voigt gets the horse. Voigt got the worst part of it because he got a little bit less than 33 and a third, which I'm trying to share with you as kind of a fair share between three people as far as how they feel, I guess. So you move to a house, you have three teenagers, and you have 3 bedrooms. Usually the oldest gets the best and so on and so forth. Say they're triplets. So there's no age, discrimination about who gets what. Is that discrimination? I don't know. So then you have your 3 teenagers. All right, go sit in your, not your rooms because you don't have them yet. Go sit in the basement in 3 different corners. I know there's 4. Someone gets 2 choices. Forget about that. All right. And then put some numbers on what room you like best. And the numbers have to add up to 100. So teenage A, let's keep it in this column format, really likes room 2. Now they really pick some odd numbers, but so in his or her mind, I like a 58 on room 2, and I guess I like room 1 a little bit better than room 3. That's what these numbers mean. They're my like numbers, how much I like it. And like I said, I probably as dad, you have to have at least a 10 on a room. You can't put a 0. The next teenager, B, they don't know they're doing this, by the way. All these are independent. I really like room 1, so I'll put a 52 on that. And I like room 2 almost twice as much as room 3, 3117. They come up with the numbers. And they have to add up to 100. Then the last teenager, I really like room 2. And room 1 and 3 are very close to each other. I guess I like room 3 a little bit better. I don't know. Just trying to get you to understand what's going on here. By the way, how many people are there? How many people could choose room 3? I'm just doing this for fun. 3. Then how many are left for room 2? 2. And how many left for room 1? 1. 3 times 2. There's 6 possible ways these rooms can be laid out. Okay, so now, go back. I'm just going to say teenager A, B, C. I'm going to make this simple. Now pay attention to this, because this is what some of you guys are missing. I could put teenager A in room 1. Well, who can I put in room 2? B, and who can I put in room 3? Or I could put teenager A in room 1. I could put C in room 2 and B. Those are 2 different scenarios with teenager A being in room 1. These are all the possibilities the rooms could be given to the teenagers. The first and the second are different. Or, who could I put in room 1, which we didn't talk about? B, well, who could go in room 2? And then who could go in room 3? Or, B, C, and then A. Or, C could go in room 1. Now that's different. C never got room 1, did they? So C got room 1. Who could go in room 2? A, and then who could go in room 3? Or, C, B, A. These are all different room arrangements. These are all 6 different scenarios how the teenagers could be placed in the room. Now what do? We put what next to them? Numbers. Now let's do that real quick, then I'll go offline for that. What is room 1? Teenagers A, room 1s. So put 22s and 22s there and there. And then it's nowhere else. Now what I do with B is this. What's teenagers B's room 1? I'm sorry, room 2, sorry. So B's room 2 is what? 31. Now, right now I'd put 31 and then find a B in this room 2 scenario. This I'd fill out the numbers because it goes quick then. What's C's room 3 like? 24, and then find if you see C anywhere else. I didn't do this first hour. It's the fastest way to do it. Okay. Okay, as the innocent little children walk out the door, I'm going to actually... What's the matter? What was that look for? I'm going to fill out the rest of this chart and do this as period 6 comes in. So, teenager B gets room 1. That's a 52 and a 52. Bye-bye. That's a teenager. See room 2 for teenager. Oh, I feel like I'm going to screw up here. So goodbye. Room 2 teenager A is a 58. 58, 58. By the way, this is the best scenario ever because what happens right off the bat makes this very simple. And then let's go teenager B in room 3. B3. You sank my battleship. I'll be here all week, unfortunately for some of you. All right, room 3, B7, yeah, 17. And now I'm going to put a 17 there. Okay, then or C could get room 1. C, room 1, 22, 22. And then all I have to do is, I have to go back. I screwed this up, but now I have to go back in room 2 for C. What's room 2C? 54. So I did miss something. I think I skipped this as people were saying goodbye to me. How dare they? And then room 3A, put a 20 and a 20. All right, finally did it. All right, the map. Step 3, find the smallest number in each scenario given to the students or the kids. Don't listen to this. In first hour, I picked all the wrong numbers, so let me make sure I do this right online. 20, 54, 50. I think 20 is the smallest. 17, 58, 22. I think 17 is the smallest. 20, 31, 22. 20 is the smallest. Now, of these scenarios, which number is the largest? This one. Is there any ties? No, there isn't. This is step 3 star. This is find the maximums of those little smallest point values. If there is exactly one and only one arrangement that has the largest number, that is it. The scenario is over. The rooms are given to the kids. So, how many arrangements are there for which the smallest number is as large as possible? Only one, which is awesome, which means this is over. This means room 1 goes to B, room 2 goes to A, room 3 goes to student C, and I swear to gosh, I'm going to suspend someone for trying to mess me up right now. And that's someone from period 6.